the task is that you want to find the slope at just this one point that just barely kisses that sucker, just a little bit. And so now I say slope, but you know, it's an ever-changing thing because if I move the point around, you know, see how like stuff's moving around? Like that slope is, the slope of that line is changing all the time. So I need to be able to find the slope at any given point. So that is what the task is. Here's the problem. Up to this point in algebra, then you can't find the slope with just one point. Algebra is just like, I need 2 points. So calculus picks up from there. And calculus is like, okay, fine. I will give you a second point for now, and we will put it right here. Or let's see, and then we're gonna give it a name. And the only thing that I'm gonna tell you about it is that there's some distance, we're gonna call it h, and it's right here. Do you see the green part right there? So this green part that's right here, this is how big h is. And what that means is it's how far away the point that you're given is away from the point that we're kind of using right now. So there's a little green bit like it's this far away. So now calculus looks back at algebra and it's just like, okay, fine, you happy? So here are 2 points. Can you find the slope of that? So the next task would be if you have these 2 points, one of them starts at x and the other one starts at x plus a little extra, which we're going to call x plus h. Well, can you find the slope given those 2 points? Do you remember the slope formula? When you found the slope, it should have revealed the difference quotient. And we are boring when we name things because there's a minus sign and then division, so therefore it is the difference quotient. So that is the thing that we are looking for. This is the slope. I'm calling mine g of x over here on Desmos because I want to show you some cool stuff about it. But when I do, I want you to understand that the difference quotient was a slope the whole time, because a lot of calculus is going to be, okay, like what's the slope of this thing and how curvy is this thing and what is the rate of change? What is the instantaneous rate of change? And that's going to be a lot of what we look at, especially in Calc 1. So therefore, we're going to be talking about slopes a whole lot. So the difference quotient that you would have learned before was actually a slope the whole time. But we have some fun stuff that we need to talk about here. I'd like for you to pause right now. You see that my f of x is negative x cubed plus 5x minus 3. Find the difference quotient of that and see if it matches my g of x. This line is going through at 2 points, which means that it is a secant line. The 2 points make it a secant. But as we move around, you see that I have h fixed so that the length of that little green bit is going to stay the same. And that just represents the amount of space between the 2 points. So, something like this. Now, we want the h to be nothing because the goal here is for this to scooch on this way, because I'm really just trying to find the slope at this 1 point, not 2 points. So if I can scooch it closer and closer, you see I get a better estimation of the line. And as I move this around, it's going to get, they travel with each other a little bit better. But what I really, really want is for my h to become 0. That's my ultimate goal right there, is for one of these points to be on top of the other, and the green line has completely disappeared. So the problem with that, though, is that if h is 0 and my difference quotient is over h, then algebra gets really upset because you can't divide by a 0, so h is not allowed to be 0. So if I have any space between them, it's a secant. But we want no space between them, or a tangent, and that creates an algebra problem. So algebra complains like, I can't do it. And then calculus is like, oh, you're so needy. Fine, okay. So we're not going to say that h is 0. We're going to say that h can get really, really close to 0. Does that make you happy? And that's why we have this limit notation, is because we can't say that h is 0. We can say that h approaches 0, the limit as h approaches 0 of the difference quotient, because the difference quotient is really a slope. Now, we also notice that right here with our difference quotient, once you simplify things, then there's no h in the denominator anymore. So we could just say, if h is 0, then this goes away and this goes away. So we end up with negative 3x squared plus 5. And we're going to get there eventually. So you see, it really poses no algebraic problem anymore, but it's the idea of it. It's the concept of it. And we can't do that. But the thing that you need to get right now is that h gets real close to 0, and the difference quotient is a slope. If I'm calling it g, notice right here that this is my slope right there. So do you remember from algebra class when you were looking for the equation of the line, it would be y minus y1 is equal to m times x minus x1. So if I'm calling my coordinate a comma f of a, then that means that this is where my y1 goes, this is where my x1 goes, and then my difference quotient at that spot is going to be where my slope goes. So this is that same point slope form of a line. Now, if h is 0, then notice how as this moves around, then I can find the slope at any point, and I can find the equation of the line that just kisses it at one spot, aka tangent. Tangent just means it touches in one spot as opposed to touching in two spots. And I can also turn this one off now. So I just need this one. See? Travels around, living its life. Find the equation of the line at any point.